In this unit, we're going to be talking about oxidation and reduction reactions. They are also known as redox reactions. We will also take a look at electrochemistry, which is the chemistry that is involved in how a battery runs. To be successful in this unit, you need to be able to assign oxidation numbers to ions and also elements in compounds. Some of it will be review and some of it will be a little bit new or a little bit different. This information in the following slides is also found in your homework assignment. So let's start off with the rules for assigning oxidation numbers. First of all elements have oxidation numbers of 0. So looking at this balanced equation, we see that our first element, zinc, will have an oxidation number of 0. And there's one more element here, and it is hydrogen over here on the end. So even though it's a diatomic element, it's still an element. So it will have the oxidation number of 0. Don't worry about the quantity that you might see here. So there are 2 hydrogen atoms. They both will have an oxidation number of 0. The next rule is if you have a monatomic ion, that is an atom with a charge, the oxidation number will be whatever its charge is. So the first thing I have here is this iodide ion, and its charge is -1, so that is its oxidation number, a -1. The Cl2 is an element, so it has an oxidation number of 0. And then I have chloride ion, oxidation number of +1, and then next the element iodine. So this is how you would assign the oxidation numbers for everything in this reaction. So even though I have 2 of these chloride ions, each one of them will have a -1. Do not say that the total oxidation number is a -2. That is going to lead you down the wrong path. You want to just represent the oxidation number as if you only had 1. Rule number 3, the oxidation numbers of the atoms in a compound add up to equal 0. So we've seen this in a previous slide, but our first element here, zinc, oxidation number 0. And next we come to hydrogen. So looking on the periodic table, we see that hydrogen is right above the alkali metals. And the alkali metals have a charge of a +1. And in this case, hydrogen also has a charge of +1. And to cancel out the charge of that +1, that means the chlorine needs to have a -1. Because a +1 and a -1 will cancel each other out, and it will equal 0 or be neutral. Next we have zinc chloride. So zinc, we may or may not know the charge of it, but we can find out what zinc's charge is by what it's with. So chlorine is a -1, and there's 2 of them for a total charge of -2. So that means the zinc has to be a +2. And in fact, looking on the periodic table that lists oxidation numbers, you'll see that this is the only oxidation number for zinc. So one more thing in our equation, hydrogen, the element, is a 0. So once I do the math, I don't need it anymore. So don't put the math in the oxidation numbers, and I can just go here and erase my math. So what's important is the oxidation number as if I had only 1 of that element. Rule number 4, the oxidation numbers of the atoms in a polyatomic ion add up to equal the charge of that polyatomic ion. So whatever charge is listed, that's what all the elements in that polyatomic ion will equal. So looking on my periodic table, oxygen has a charge of -2, and I have 3 of them for a total of -6. Now altogether, the nitrogen and the oxygen have to equal a -1. So what will the nitrogen have to be? It will have to be a +5. So in math, you would just write 5, but in chemistry, you need to write the plus also. So +5 and a -2 are my oxidation numbers. Nitrogen is a +5 and each oxygen is a -2. But I don't want to say oxygen's a -6. It's a -2. Don't put the math in it. Let's come to this sulfate ion. So again, oxygen -2. If there is an oxygen, most likely it is a -2 charge. We're going to talk later on about the exception. But all the oxygens together is a -8, and it has to equal a -2 altogether. So that means this sulfur is a +6. So sulfur is a +6, and oxygen is a -2. And this arsenate ion, again, oxygen's a -2. And altogether it has to equal a -3, so that arsenic atom has to be a +5. So again, the polyatomic ions, they add up to equal that charge on that polyatomic ion. So looking on your periodic table, we can see that we're used to saying that sulfur has a charge of a -2, but that is when it's with a metal. So this is sulfur with a nonmetal, and because of that, its oxidation numbers can be a little bit different. And the same thing with the nitrogen. We're used to looking on the periodic table and saying that a nitrogen has a charge of -3, but that's only if it is with a metal. And so here it's with a nonmetal, and so the rules of that -3 kind of go out the window. So you'll see that nitrogen and sulfur, when they're in a polyatomic ion, they can have very different polyatomic ions. And you really can't memorize it. You just have to look and see what it is bonded to. And in this case, in both of them, it's bonded to oxygen. So oxygen has a -2 charge, and then you can just figure it out from the polyatomic ion charge and the oxygen oxidation number. All right, rule number 5. So why did I start with oxygen? It's because most of the time oxygen is a -2. So it's really something you can depend on it. And you can depend on hydrogen too. Hydrogen has a charge of a +1. So there are an exception for each of these. So for hydrogen, there's one exception, and for oxygen, there's one exception. So I'm just going to give you some examples so you can watch out for those exceptions. So hydrogen is a +1 except if you have a metal hydride. So that means when it's with a metal, then the charge becomes a -1. Usually you can figure out that hydrogen is doing this, is accepting an electron, because you can figure out the oxidation number of the metal, and that will help you figure out the hydrogen. Oxygen is a -2 except for when we have peroxides. And the only peroxide that you need to know is this one, H2O2. So when you have a peroxide, the peroxide anion really looks like this. So it's a little bit different. Each oxygen in that peroxide has a charge of a -2. So let's go ahead and assign oxidation numbers to each of these molecules. So first of all, carbon monoxide. So oxygen's a -2. I have 2 of them for a total of -4. So that means carbon has to be a +4 so that they'll equal 0. So again, the oxidation numbers are what's important. So carbon is +4, oxygen is -2. Let's come over here to this H2O2. Hydrogen is a +1. I have 2 of them for a total of +2. And that means that both of my oxygens together have to equal a -2. And since I have 2 of them, each of them is a -1. So this is the exception to that oxygen rule. So again, our hydrogen is going to be a +1 and our oxygen is going to be a -1 in this case. So this is the exception that you'll want to look out for. And this next one has both hydrogen and oxygen. And so I can assign oxidation numbers for the oxygen and the hydrogen. And I can look and see what charge is left, so what sulfur will be. So I know that my hydrogen, they add up to equal a +2. And my oxygens add up to equal a -8. So that means my sulfur right here in the middle has to be a +6. So your answer is right here, just the top. So again, don't put the math in the oxidation number. So hydrogen's a +1, sulfur's a +6, oxygen's a -2. I just do the math to help me figure out what that middle one is. And this next one, this lithium hydride, this is the exception to hydrogen, where it's not being a +1, where it's not losing an electron. So lithium is a +1. It's always a +1. So that forces hydrogen to accept that electron and be a -1. And this is a rule that you should already know. So the first group, the alkali metals, the 1A metals, they are always a +1. Also, your 2A metals, they are always a +2, so you can depend on them. You also should know about aluminum. Aluminum is used commonly in the lab, and so you should know that an aluminum compound has a +3 charge. And there's a couple others that I would like you to know. So Looking at aluminum and going down diagonally, you can find zinc. Zinc is always a +2. So when you see zinc in a compound, it will have a charge of a +2. And you should also know that silver is a +1. So if you go down diagonally starting at aluminum, it goes +3, +2, +1. Aluminum, zinc, silver. So it's kind of an easy way to remember those. And those are all used very commonly. So you should be able to figure that out. All right, let's go through all of these. I'm just going to go really quickly through their oxidation numbers. Sodium is in group 1A, so it has a +1. So that means that chlorine is a -1. A +1 here, a -2 here. I have to do some math to figure out what that chromium is going to be. And I find that it's a +6. And again, those are the oxidation numbers. Lithium +1, oxygen -2, hydrogen +1. Magnesium, alkaline earth metal, is a +2. Oxygen is -2, and there's 3 of them for a total of -6. So carbon is a +4. And the reason why I worked that out is carbon can sometimes be a +2. So I wanted to make sure which one I had. Calcium is a +2. Oxygen is a -2. And a total of -8. And there's that sulfate ion there again with that +6. And then we have aluminum, which is a +3. I do have 3 of them, which is a +6. And oxygen, -2. And we see that they total up -6 to cancel out that +6. So this is how we assign oxidation numbers. And again, that top number is what's important. That is the oxidation number as if I had one of them. So don't put your math in the oxidation number. Halogens are -1 when they are bonded with a metal. So we have calcium right here with a +2. Iodine will be a -1. I do have 2 of them, but we see that they will cancel out. And then potassium is an alkali metal with a +1, and fluorine is a -1. So it's a neutral compound. And this is my favorite rule: fake it till you make it. So use the periodic table to help when you don't know where to start. And also you can use the charge on polyatomic ions. So let's look at this first one. We have lead sulfide, but is it lead 2 or lead 4 sulfide? Because lead can have one of those two oxidation numbers. So I'm going to look at sulfur and look on the periodic table, and you can see that sulfur is right under the oxygen family. And so we are going to guess that sulfur has a -2 charge. And we would be right because this is lead 2 sulfate. Excuse me, sulfide. And let's look at this next one. So copper can be a +1 or a +3. Let's look and see what it's bonded with. Chlorine bonded to a metal is a -1 because it's a halogen. So that's a total of -3 with the chlorine. So that means copper is a +2. And next we come to iron sulfate. But is it iron 2 or iron 3 sulfate? I can look up this sulfate polyatomic ion, and I see that the charge of it is a -2. So that tells me the charge of the iron. My iron is a +2. So this is kind of the fake it till you make it, using those polyatomic ions to help you. And then I can fill in the oxidation numbers for the sulfur and the oxygen. So in this next one, this is a +1. My phosphate, I can look that up. It has a charge of -3. And so very quickly I can figure out the charge of that phosphorus atom, and I find that it's a +5. And our last one, we have carbonate right here, which has a charge of a -2. And that goes along with this rubidium that is an alkali metal with a +1 for a total of +2. And so to make this all work, this carbonate, my carbon, has a charge of a +2. So just to practice, stop the video and go ahead and assign oxidation numbers to all of these compounds, and then come back and we'll tell you the answers. Okay, we're back now. So our hydrochloric acid, a +1 and a -1. On this ion, it has to equal a -1, and I do have one oxygen. So that means that this the chlorine in this polyatomic ion is a +1. Now we have chlorine in a different polyatomic ion, and this ion has to equal a -1 also, and now the chlorine has a +7. Our ammonium ion, hydrogen is a +1 and the nitrogen is a -3. And if you do the math for the hydrogen, you'll see that everything works out. The charge is a +1 as shown. Carbon monoxide, oxygen is a -2. That means the carbon's a +2. We have H2O2, so that is a peroxide. So hydrogen's a +1 and oxygen is a -1. And last, the potassium sulfate. We have, if I work out my oxygens, we can see that that sulfur needs to be a +6. And I do have 2 of these potassiums for a total of +2. So a +2, a +6, and a -8, that all is neutral. But again, it's that top number that's important. So those are the oxidation numbers of the potassium, the sulfur, and the oxygen.